Hello everyone. Okay, we meet again for the last subtopic of group 14. Okay, silicones, glass, right, ceramic. Okay, but now I want to explain the overall uses of silicon. Okay, for the first thing, silicon is major uses in electronic industry. Okay, which is usually we use silicon as a semiconductor, computer chip, transistor and solar cell. Okay, the second uses of silicon is a silica gel. Okay, which is, as we know, that silica gel is usually used as drying agent due to the higher surface area. Okay, the third one is the uses of silicon in form of silicon dioxide, okay, and silicates. Okay, which is silicates mostly using in making glass, ceramics and cement. Alright, okay, number 4, silicon is used to make silicone. Okay, this one we will explain further after this. Alright, then the last one, silicon is used to make alloy. Okay, focus on solder, pewter and bronze alloy. Yes, now we go to silicones topic. Okay, what is silicones? Okay, silicones is a silicon, okay, which is bonded with organic polymer. Alright, silicones is a synthetic organosilicones polymer containing SiO(Si) bond, okay, which is also bonded, okay, with alkyl, okay, or aryl group, okay, attached. Okay, so SiO(Si) is also bonded to the aryl group. What is alkyl? Okay, what is alkyl? Okay, alkyl is actually, okay, the functional group, okay, which consists of carbon, okay, and hydrogen, okay, which is substituted in a parent chain. Alright, so that we can see that for silicones it consists of, okay, SiO bond, okay, and it also have Si carbon bond. Alright, which is C is referred to the alkyl group. Alright, for the general structure, okay, of silicones, okay, now, okay, we have SiO bond, okay, SiO bond, okay, which is SiO bond, okay, now, okay, which is this Si, okay, this Si also form bonding, okay, with, okay, alkyl group, okay, bonded with alkyl group. Okay, so these are, okay, R is a alkyl group, okay, alkyl group. Okay, what is alkyl? Example of alkyl, okay, we can see here CH3, which is, we call it as a methyl. Okay, we also have CH2, CH3, alright, okay, or C2H5, okay, which is, we name it as a ethyl. So this is the alkyl group. So that's why, so the example here is, okay, SiKO, okay, SiO bond, okay, and then this Si, okay, example I take methyl, so it bonded with methyl group. Okay, so this is the example of silicones, which is bonded with oxygen and also bonded with alkyl. So that's why, okay, for silicones, okay, it is a strong bond because of it consists of SiO bond and also SiC bond, okay, SiC bond. So this make the silicones is resistant to chemical corrosion because it consists of both strong bond. Okay, now what is the repeating unit? Okay, in this structure, so we can see the repeating unit here is, so the repeating unit here you can see, okay, this one is part. Alright. Okay, now so the repeating unit here is, okay, repeating unit. Okay, so we can write here, okay, SiCH3, okay, bonded with another CH3, okay, and then bonded with O. So this one is belong to another unit lah. Okay, when we put N here as a polymer lah. Okay, so this is the repeating unit of silicones. Okay, so in silicon topics, we continue to explain about preparation, okay, of silicones, types of silicon and uses of silicon. Okay, but now is the preparation of silicones. Alright, okay, in order to prepare the silicones, okay, the first method, okay, we have 3 steps. We have 3 steps in formation of silicones. Okay, for the first method, we must prepare the alkyl chlorosilane. Alright, in preparing the alkyl chlorosilane, okay, we have 2 methods. So we can choose either we want to use the first or second method. Okay, for the first method, we passing the alkyl halide, okay, which is HCl, okay, which is HCl vapor over silicones, which using copper catalyst 300 degree Celsius. So this is the chemical equation involved. So we have alkyl halide here, CH3Cl, okay, react with silicon, okay, and then we use the copper powder and 300 degree Celsius. So we will get dichlorodimethyl which is, so this is the alkyl chlorosilane. Alright, or we can use the second method, which is by action of silicon tetrachloride on Grignard reagent. So this Grignard reagent we will learn in detail, okay, in term 3. Okay, but now this is the chemical equation involved, okay, which is, this is the silicon tetrachloride. We react it with Grignard reagent, okay, and then we will get the alkyl chlorosilane that we want. Okay, this is the dichlorodimethyl silane. This is the side product from the Grignard reagent lah. Alright. So this is the first step, okay, in formation of silicones. Alright, the second step, okay, after we already prepared the alkyl chlorosilane, okay, then we hydrolyze of the alkyl chlorosilane. Alright, so this is the equation involved, which is we have chlorosilane here, okay, and then we give water, react with water, which is we hydrolyze it, okay, and then we will get the hydroxyl compound, which is this Cl will substitute by OH, and then we remove 2 mole of HCl. So this is the hydroxyl compound. Alright, so this is the hydroxyl compound. Alright, so first and second step. Alright, now third step, okay, we do the condensation polymerization of hydroxyl compound. Alright, so this is the reaction. Alright, so now we have silicon, okay, we have hydroxyl compound here, okay, and then we react with another hydroxyl compound, alright. So now we will do the condensation polymerization, which is we will remove the water here. So meaning that we remove the water. So what is the product that we will get? Okay, so we will get the Si. Okay, so Okay, this is the product. So this left O here. Alright. Okay, so this is the SiO-Si bond. Alright, so okay. Okay, or we can write it in terms of polymer lah. Alright, so this is the polymer structure of silicones. Okay, now from this product form, okay, I will already rewrite here. Okay, so now, so this is we call as a linear silicon polymer. So this is linear silicon polymer. Alright, okay, because it's one layer only. Right, so now I move to the types, okay, of silicon. Okay, which is we have three types of silicon. The first one, okay, is linear silicons polymer, which is in a one chain only, one linear shape saja. Alright, okay, and we have the second one. The second one is, okay, we have ring, okay, silicons polymer, and the third one we have cross link, okay, silicons polymer. So I just want to focus on the linear and the cross link silicon polymers only. Okay, but now, okay, how to form the cross link silicons polymer, and what is the difference between the linear silicons polymer? Okay, now I want to show how to form the cross-link silicon polymer. Alright, now I will start the reaction by using the alkyl chlorosilane. If you can see here, this chlorosilane consists of 3 chlorine atom. Okay, so now for the first step is we hydrolyze first. Alright, when we hydrolyze, okay, we hydrolyze the alkyl chlorosilane, okay, which is we added it with H2O. So we will get that it consists of 3 OH. Okay, now we have 3 OH. Okay, hydroxyl compound. Right, but now is, okay, we do the condensation polymerization. Okay, let's do the condensation polymerization here. Right, then, okay, what happened is, okay, I will use by using, okay, now we have CH3, okay, then is OH, okay, 3 OH each. Okay, so now let's say that I want to use the condensation polymerization by using the 6 monomer of silicons. 1, 2, 3, 4, 5, and 6. They have 6 compound of hydroxyl compound. Okay, now, okay, when all this being react, which is condensation polymerization is occur, so now we will remove the water. Okay, we remove all the water involved here. Right, okay, we remove the, okay, water here. Okay, now we remove the water. Okay, we remove all the water involved. Okay, we remove the water. Right, so now 1, 2, 3, 4, 5, and 6. So let's say that we will remove the X water here, the side product. So now what is the product form that we can draw here is it have SiO bonding, okay, from the water removed. Right, so okay, so now this is the product form from the condensation polymerization in form of cross-link silicons polymer. So you can see here that they have a cross-link, okay, between one layer and the second layer of silicons. So this is the cross-link silicon. right? So this is the types of silicons. Okay, which is what is the advantage of this cross-link silicons? If you can see here that, okay, with this cross-link, okay, cross-link of silicons here, we can see that this can cause the silicons become, okay, these silicons, okay, become harder, okay, become harder and can withstand, okay, can withstand heat, okay, better than single chain silicons. So this is the advantage of cross-link silicon, which is a very good, which is harder and can withstand heats better than single chain silicate, which is this one lah. Okay, finally I want to remind again, okay, how to identify, okay, what is silicons here. Alright, so the first thing is you see that it have SiO bond and also it have SiC bond. So this is shows that this compound is silicons. Okay, same goes to the cross-link silicons, which is it have SiO bond and also it have SiC bond. Alright, this shows that this is the silicons. And how we take a look about the repeating unit. So this is the repeating unit of silicons, which is we must write it, okay, like this lah. Okay, CH3, okay, and then, okay, don't forget to show O here, okay, and then you put N here. This shows that it from the polymer, long polymer lah. So this is the repeating unit. Okay, now refer to our chem book, page 103. Now I give already the example of polydimethyl siloxane, which is PDMS, and actually is the structure of PDMS is that the diagram that I draw earlier. So this is the silicons formed from our reaction, and actually this is we call PDMS. Alright, okay, so now then I want you to complete this diagram lah. Okay, I already covered about preparation, okay, and types. Okay, now we take a look the uses of silicons. Alright, so now, okay, this is the uses of silicons, okay, which is the properties strong SiO bonds which make it resistant to chemical corrosion, okay, which is this bond make the silicons become inert, okay, and non-toxic. Alright, okay, which is this strong bond, okay, cause the silicons become inert and non-toxic. Alright, so what is the uses? Okay, to make sealants for glass, ceramics and metals in building and household part. Okay, it's also stable to heat and light, okay, because of the strong bond. Okay, so it can use as a silicon fluids are used as a lubricant, okay, in high temperature equipment because of its stable to heat. Okay, and then, okay, the silicons also non-toxic, which is we can use a silicon elastomer, okay, in making the surgical implants. Okay, and then silicon resins are also used as an insulator for wire casing and pot holder. Okay, okay, the last one for silicon, because it have the alkyl group, and we know that this alkyl group are hydrophobic, which is insoluble in water. So that cause the silicons is a good water repellent, okay, which is also silicon fluid also used to make car polish. So this is the uses of silicons. Okay, now we move to the another uses of group 14, okay, which is in making glass. Okay, the second one is ceramics, and the third one is tin alloys. Okay, we know that tin is included in a group 14. Alright, now we move to the glasses. Alright, for glass, okay, we can see that, Okay, when SiO2 is heated to its melting point, right, the SiO bond break and it melt to form viscous liquid. Alright, okay, which is we have silicon dioxide and we heat, okay, we heated to its melting point. Okay, but it cooled rapidly. Okay, after it melt, it will cool rapidly. Okay, which is silicate glass, which is quasar glass is formed. And we know that quasar is a part of framework silicate. So this is the quasar. So quasar is a framework silicate, which is its content of SiO2. Right. But now is, okay, we see that this quasar glass contain of silicon and oxygen atom. Okay, but it's not arranged in a regular manner. So that's why the glass is a amorphous solid. Alright, because it cooled rapidly. Right, so it become the amorphous solid. Alright, they are chemically inert except to concentrated alkalis and hydrofluoric acid, which is for SiO2. Okay, it will react with sodium hydroxide, okay, and hydrofluoric acid only. Alright, so that's why we write the equation here. So this we already covered in acid-base property of oxide of group 14. So which is SiO2 react with NaO to form sodium silicates and water lah, because this is the neutralization process, because SiO2 is acidic. Okay, hence hot concentrated alkali should not be stored in glass container. So that's why for glass which contain SiO2, we cannot put an AOH in the glass because it will react to form sodium silicates. Right, this is we call sodium silicates. Alright, now the property of glass. Okay, now this is the property of glass. We have transparent, inert towards many chemicals, hard and brittle, and non-porous. Okay, now they have a few classes of glass. Okay, they have many types of glass. Right, we have quasar, which is the pure SiO2. Okay, which is this part we use in a fiber optic lens, making lens, we use quasar. Okay, and then we also have soda lime glass. Okay, which is if you realize that all the type of glass must contain the SiO2. Major component in each glass contain of SiO2. Right, so this is all the framework silicates. Right, now back to the type of glass, soda lime glass. It have sodium carbonate and calcium carbonate, also aluminum carbonate. So which is this resistant to corrosive chemical. Okay, which is usually we use it in a drinking glass or bottle, water. Okay, water bottle. Okay, or window panes. So this is made up by soda lime glass. Okay, and then we have potash glass. Okay, this is just we extra the potassium carbonate, which is hard. Okay, and the major uses in combustion tubes. And then lead glass. Lead glass, we just only added lead ore and sodium carbonate, which is mostly used in prism, chandeliers. Okay, which is it have higher refractive index. Okay, and then the most common that you usually use is borosilicate glass, which is usually we use apparatus in lab. Okay, you can see that it use Pyrex glass. Okay, which is this Pyrex glass or borosilicate glass content of B2O3, sodium carbonate, calcium carbonate, and aluminum oxide. So this kind of glass resistant to corrosive chemical. Okay, which is it can withstand to high temperature. Okay, so we usually use as a test tube, cooking utensil, laboratory glassware. And the last one but not least is aluminosilicates glass. Okay, which is we have SiO2, B2O4O3, and Al2O3 here. Okay, and MgO, MgO here. Okay, MgO. So this kind of glass can withstand to high temperature and thermal shock. Okay, usually we use in a oven wares. Okay, usually we make a container which can use in oven. Okay, this is about the glass. Okay, now we move to ceramic topic. Okay, which is this ceramic are aluminosilicates made from clay. Alright, made from clay. So we take a look again. Okay, for the framework silicate, which is the example of framework silicates. Okay, we have quartza, feldspar, clays, and zeolites, and this also included in framework silicates. Right. So now is ceramic. Okay, what is the properties of ceramic? Okay, it have higher melting point, chemically inert, heat resistant, hard and brittle, also good insulator. Alright, and then what is the uses? Okay, the uses of ceramic. Okay, now it have hard and strong, which is can use as a brick, tile, and cement. Right, okay, building material. We have attractive in appearance. We use as decorative item. Okay, usually used as a porcelain vase. Okay, and then electrical insulator, also use ceramic. Okay, to make insulating part in electrical equipment. Okay, usually we use as a toaster and iron. Okay, and spark plugs. Okay, and then chemically inert and non-corrosive. Okay, we use in a household material, which is plates, bowl, and cooking utensil. Okay, and the last one is a heat resistant, which is we use it, okay, in a refractory lining of furnace, okay, to become heat insulating layers. Okay, this is the ceramic, which is example of ceramic here is usually feldspar, KAlSi3O8, which is feldspar is also the example of framework silicate. So this is the clay lah, which is ceramic example of ceramic. Okay, the last uses as a tin alloy. Okay, for the tin alloy, okay, it used widely in electroplating, okay, which is tin plate iron in making tin cans, because tin is not toxic. So that's why we usually use tin, okay, in electroplating. Alright, but now I use that I give 3 example of alloy that contain of tin component. Okay, which is the first one is solder. Okay, for solder, okay, it contain of 70% of lead and 30% of tin. Okay, and then pewter, it contain of 96 of tin, 3% of copper, and 1% of antimony. Okay, and then finally is bronze. Bronze contain of 88% of copper and 12% of tin. Okay, now I want to show you that how to memorize, okay, this alloy. Okay, example, we have solder here. Okay, we have solder, okay, which is solder contain of lead and tin. Okay, and then we have pewter here. Okay, pewter contain of tin and copper, also antimony, but it's minimum. Okay, and then we also have a bronze, okay, which is contain of copper and tin. So they have some method in order to memorize this component of element in a solder alloy, pewter alloy, and bronze alloy. Okay, the first one for solder, you can use that Siti is public singer. Siti Nurhaliza is a public singer, which is S stand for solder, okay, P stand for lead, okay, tin stand for tin. Alright, and then the second one, pewter. Okay, for pewter, okay, I use Pua Cukang. Okay, Pua Cukang is that everyone know. Okay, Pua Cukang is stand up comedian. Okay, so P is stand for pewter. Alright, S stand for tin. Okay, and then comedian is stand for copper. So this is how you memorize it lah. Okay, finally is bronze. Bronze, okay, I use Brad Pitt. Brad Pitt. Okay, Brad Pitt is cute. Okay, is a cute, right, stuntman. Okay, Brad Pitt is a cute stuntman, which is B stand for bronze, C stand for copper, and S stand for tin. And the first word is referred to the major component, okay, in this alloy. Okay, we done covered the whole topic of group 14. Okay, see you again.